Okay, so greetings to all of you. This is your course instructor, Khushwant Fatnani. We are studying, we are doing a revision of class 11th syllabus right now, and we are seeing in today's syllabus coverage and practice the chapter Gravitation, a very important chapter. But before we start, like always, let us start it with prayer and meditation. So request all of you to kindly join your hands, close your eyes, and bring a broad smile on the face. Come back to the moment. Let us all come back to this moment. All the attention on the breath. One by one, we take 3 deep breaths and count. Count 1. Deep breath in and breath out. Let the smile stay on the face. Once again, take a deep breath in and deep breath out. Once again, take a deep breath in, slowly and with a smile on the face, and deep breath out. We'll pray. Dear God, we thank you for this life and all the gifts of life. We thank you for such good health, wealth, and wisdom. We thank you that we are blessed and we are loved. Dear God, we thank you for your blessings, guidance, and motivation we are receiving through our parents, family, great set of friends, and great mentors. Dear God, I thank you in advance for clearing joint entrance examination and NEET examination in the year 2020, in the year 2021 in flying colors. Thank you that I've got admission into the college of my dreams. Thank you in advance for all your assistance. Thank you, thank you, thank you. In the name of God, let us open our eyes slowly and steadily with a smile on the face, and let's start. All right, class. Thank you everyone for your presence in the session. Let us begin. So in case you all have gone through the formulas, the list of formulas which I had sent you, please raise your hand. If you have once just seen through the formulas, we'll quickly see them here. I sent you all the formulas for the chapter Gravitation. In case you have been able to look through the formulas, even if it is for just 5 minutes, I would want to see your hand raised. Yes, class. Because this will help us build on the variety of questions in the class. Yes. So I can see Samriddhi has gone through the formulas. Atul, Manjunath, Siddharth, Harsh, Ayush, Karuna. Okay. Mahila. How about you, Monica? Have you been able to once look at the formulas? In case not, you can still go through them like right in now itself. Okay, yes, I think everyone has seen the formulas once. Thank you everyone, you can bring your hands down. Yeah, let's start there. So class, in today's session we are going to discuss beyond those formulas, right? What are the important techniques and tricks that we should remember while solving the questions, right? And how are we going to solve the questions from the past years and the most probable questions for this year, JEE 2020, right? So we are in the revision class, right, for JEE and NEET preparation. And we are seeing in the class some basic approaches. What are the basics, right? And we are also seeing some most probable questions, and we are solving past year questions. So in the chapter which we are going to read today, that is gravitation, around every year 1 to 2 questions are asked in your examinations, right? Although the distribution is not very high, but then the kind of questions which are asked are so easy that if you are thorough with this chapter, you are in essence fixing these marks for yourself, that okay, this is the mark which is definitely mine, or this is the question which is definitely I'm going to be correct with in my examination, right? So the distribution is around 1 and maximum 2 questions in one of the examinations. So I'll give you I'll give you an example. So in the year 2019, right, in one of the shifts, 8th April, there was one paper that was one question that was asked, right? Similarly, in second shift, that is next paper, also you had on the same day one question from this chapter, right? And in fact, in the first shift, you had one more question which was based on a very similar aspect, right? Very similar aspect. And similarly with shift number 2, right? So somewhere around this pattern, that is around 1 to 2 questions are asked every year from this chapter, right? Be it 2018, be it 2019. Let us start off. So class, I hope the formulas are clear to all of you. Just give me a second. So, dear class, let us have a quick insight of the formulas, right? Once again, of the concepts in this chapter. We all very well know that in the universe, any body which has mass attracts any other body which has mass, right? So, let's say when we are having two bodies, each of mass m1 and m2, right? There is a force acting between them, which we already know as gravitational force. Now what matters, or what is very important to understand, that we generally take this force to be equal to F is equal to G m1 m2 by r square, where r is the distance between two bodies and m1 and m2 are the masses, right? Now in the exam, what kind of questions we are asked is, let's say we have, let's take one kind of question on this pattern, right? So suppose we have one body, let's say this is earth, right? And we have satellite which is revolving around it, right? Let us take a satellite, let's say this, right, is a satellite which is revolving around earth in a circular orbit. So we'll take a circular orbit, right? In this circular orbit, we have a satellite which is blue in color, which is revolving around earth, The mass of Earth, let it be m, while the mass of satellite, let it be small m, right? Now class, there are different kind of questions which are framed on this uh, concept. So have a look on the formulas which I have sent you. One of the formulas is V naught, right? That this V naught is called orbital velocity. Orbital velocity. So the value of orbital velocity is given as under root of gm by r, right? Where what is r? R is this distance. The distance between the center of the planet and the satellite, right? What is m? M is of course the mass of the body around the central planet around which this satellite is revolving, right? So this is what is orbital velocity. How do you derive it? Very simple, right? We know that. So this understanding is important, right? This understanding is important that why is this satellite revolving? So this satellite is revolving around the main planet because there is a force. There is a force of attraction or gravitation which is trying to pull. Force of gravitation is trying to pull the satellite. Class, take a note. The satellite which is revolving, right? The satellite which is revolving, that satellite can also be called to be, it is perpetually in the state of free fall. I'll write here. Satellite is moving with a velocity v naught and is perpetually in a state of free fall, right? This is one very important aspect that you should understand about the motion of a satellite around any given planet, right? So this can be any planet. I've written Earth, but then it can be any planet, right? So yeah, this is how we are understanding the concept. Now, how do you calculate this orbital velocity? Very simple. We know that the centripetal force is what is something which makes any body revolve around the other, which we know is given as mv square by r, right? So here the velocity of the satellite is v naught, equating just this centripetal force to nothing but gmm by r square, right? So on cancelling m and m, we get v naught is equal to under root gm by r. Now, this is something really important. Why am I telling? I'll discuss it because you have such questions coming in your exam, because of which the understanding of derivation is important. So class, have a look. When the force was proportional to 1 by r square, we got this v naught proportional to r power minus 1 by 2. Correct? Have a look from here. V naught or orbital velocity is proportional to minus 1 by 2. Now, let's say, for example, this is one question from one of the previous examinations. Suppose it is given in the question that the gravitational force is no longer proportional to 1 by r square. It is now proportional to 1 by r power 5. 1 by r power 5. You are being asked, find out how velocity v varies with time, right? So v is proportional to t power n, find out n, and suppose the time period of the satellite is t, how does that depend? So I must write here r, pardon me. So how does that depend upon r? Let's say m. In the question, you're supposed to find the value of n plus m, right? So here we found out orbital velocity. Class, so here we found out orbital velocity just in the previous page. See here, right? Here we found the orbital velocity. Now, apart from the orbital velocity, it is also very easy to find out the time period of the satellite. See how we have the orbital velocity, then it becomes easy to find out time period. See how? Because we already know that speed is nothing but distance traversed by time taken, right? Now, what is the distance that is traversed by the entire satellite in one go, in one revolution? It is equal to 2 pi r, correct? So, we'll have 2 pi r upon time period giving us V naught, right? This will tell us that time period is directly proportional to r by V naught, and we know that V naught is proportional to r power n. Let's say r power n, then t will be proportional to r upon r power n, correct? Right? So therefore we'll have t proportional to r power 1 minus n. Right, class? So we right now don't know what is this n. We right now don't know what is this m. I'm just taking an example, right? So let us erase this. Just this example was given for all of you to understand that if you know the dependence of orbital velocity on r, it becomes easy to find out the dependence of t on r. I'll write this. If you know how does v depends upon r, if you know the answer to this, it becomes easy to find out how time period depends upon r, right? This answer will automatically come. That was the purpose. Now, let us derive it for a general case. Such questions are very frequently asked in this chapter. Let's say force is depending upon 1 by r power n. So let me now take the help of one of you for this. So can I have Siddharth speaking? Yes, Siddharth. So Siddharth, let's say I have force proportional to 1 by r power n, right? This is the value of gravitational force given to us. So I'll be unmuting all of you. Right. So now, Siddharth, that we are given this, can you tell us the approach? How should we go about finding the dependence of orbital velocity on radius? It will be just in a manner the way we did this question, this one. Very close.
So
yes.
we already have the relation between orbital velocity and at least the gravitational constant mass and radius.
Yes. So we have force depends on force or centripetal force given as mv square by r, right? Now that is equal to
gmm
upon
by
power n.
r squared.
Now instead of r
r
power n, we have r power n. That's the difference, right?
Yes, sir.
In the question, this is a very specific case given. It is given that we know that generally f depends upon 1 by r square. But now let's say in the question a hypothetical condition is given that now the force of gravity is depending upon not r power 1 by r power 2, but on 1 by r power
1 by r power n.
Right, right. Now we have to find out how will this entire process go about of finding dependence of orbital velocity on radius and dependence of time period of the satellite.
Time period upon radius.
Right. So yeah, go ahead, Siddharth. Let me know. Yeah.
So obviously that m gets cancelled. We get and the r gets reduced by 1 power.
Yeah.
So it becomes v squared equals g times capital M divided by r raised to n minus 1.
Right. But right now, since we are concerned with proportionality, let us ignore the other constants. Okay. So, right. So we are only concerned with proportionality. So let's ignore the constants, right? So we'll have v square is proportional to r by r power n, right?
Yes,
This
sir.
gives us V square is proportional to R power 1 minus N, correct?
Yes, sir.
Now we have just one by one verify, right? And let me know if I'm going right. This is how it will go, we'll go about, right?
Yes, sir.
Right? So
Yeah.
class, if you'll verify the formula given to you in the list of formulas, it also matches with the same, just that they have taken this R in the denominator. So we have V is given by, so minus sign comes common, and of course we know that whenever, let's say we have Z is equal to x power n, it can also be written as 1 by x power minus n. Similarly,
Yes, sir.
here V was proportional to 1 minus n by 2, or we can write it as V is proportional to 1 by R to the power of n minus 1 by 2,
Yes,
right?
sir.
So, Siddharth, once go through it and let me know if the approach is clear to you. Is it clear?
Yes, sir.
All right. So this is class a kind of probable question which can pop up in your examinations, right? How
Yes,
do
sir.
you reach orbital velocity expression from the force given, right? From the force given. So this is one kind of question. Let us take next one. So
Uh,
yeah,
Time when velocity is raised by a constant.
yeah.
I mean,
Now,
radius is raised by a constant.
yes. Now let us say we have to find out how is the expression of time period varying. So now, thank you, Siddharth. Let us now
Yes,
take
sir.
Manjunath. Yes, Manjunath. So yeah. So Manjunath, can you give me an idea that how should we go about it? The calculation of time period. Even if you don't know, I'm there. I'll help. No worries. Yeah. Yes. Go ahead.
So for the calculation of time period, we will use the formula of speed is equals to distance upon time.
Absolutely correct. We have speed is equal to distance by time. Now we have a planet and around it a satellite is revolving. Okay. So what is the distance that it is undergoing or traveling?
2 pi r.
2 pi r. Absolutely. So we have time is equal to distance by speed or 2 pi r by v, right? Therefore, we have v is proportional to t by r or r by t. R by t,
So
right?
v is proportional to r by t.
Yeah. So, or and we can also write that t is proportional to r by v. Correct? Now we know we have already found in the last question that v is proportional to
Yes, sir.
1 minus v is proportional to 1, this one 1 minus n by 2,
So
right? Let's write that here.
yes,
V is proportional to r power 1 minus n by,
1 minus n by 2.
right? Now let
Yes,
us substitute this over here. So we'll have time period.
time
Yes, Manjunath. Time period.
time period is proportional to r by r power 1 minus n by 2.
Absolutely correct. Now we'll take this in the numerator, the exponential.
Yes, sir.
So this should become 1 minus n by 2, right? That is 2 minus 2 plus n whole by 2. Am I
Sir,
correct in
r
doing this?
is r power n.
Minus 1, I think, right? Here.
Yes, sir. Yes,
Okay.
r power n by 2.
R power 1 plus n by 2. R power 1 plus n by,
N by 2.
right. So, Manjunath, can you just go through this and check and let me know if we are right in our calculations?
Sir, I think sir, it should be r power n by 2.
See, have a look once again, check it.
Yes, sir, wait, sir. 1 minus n by 2.
Yeah, correct. Have a look,
No, yes, sir, correct. Sir,
right?
correct, sir.
Yeah, yeah, great.
Yes, sir, yes.
All right. So now we have class, we have described that whenever in question, we are given that how is how is the force depending upon the radius or the radius of the satellite and planet system, how it becomes very easy. to find out the dependence of orbital velocity. See here how it becomes easy to find out the dependence of orbital velocity on the radius of the satellite. Very important. What is this r? This r is not the radius of, this is not the radius of a satellite or the earth. It is the radius of the path. See here class, if this is the path, right, a circular path, here we have the satellite, at the center we have the planet, right? So between the center of the planet, and the satellite, the distance is r. Class, this is super important. Please keep this in your mind, right? This r is the radius of the, you can write if you wish, this r is the radius of path and not the planet, right? Radius of the path of satellite. So Manjunath, is this point clear to you? Or is this
Yes, sir.
derivation also clear to you?
Yes.
Very clear, right? Because you get such questions in the exam, right? Okay, great,
Okay, sir.
great. So thank you, Manjunath. Okay. Class, if this concept and the approach is clear to all of you, please raise your hand and let me see if the approach is clear to all of you. Yeah, and in case there are any questions, we'll take them up. Yeah, so please raise your hand if this approach of calculating the dependence of velocity and time period of a satellite from the expression of force given is clear. If it's clear, please raise your hand. Yes, class. Okay. Ayush, in case you have any query, yes, ask. Yes, Ayush. Okay, Ayush is also clear. All right. All right, class. Thank you very much. You can bring your hands down, right? Okay. Now, this I think everyone must be aware with one of the other formulas is the variation of the variation of G with, there are three aspects to it. Variation of G, there are three aspects to it. One is variation of G with respect to height, with respect to depth, or with respect to latitude, right? You also every year get some or the other question, just that in the exam what they do, they will twist the way they are asking the question to you in the format, or the format will change. So we all know that, so this expression should be known to all of you, right? I'll write it here. And how do we derive it? That is also very important, because in this chapter, you know what, it is important that you know the derivations, because if you know the derivation, you will be able to tackle any question, like the way I just told about this question, because they know that the students have a habit of memorizing the formulas, right? So just memorizing won't work if the force dependence on r changes, right? Just memorizing won't work. So it's important that you know how do you get these formulas. So now let's say we are talking about a body which is kept on the earth's surface, right? Here the acceleration due to gravity at this height, that is zero height, almost zero height above the earth's surface, but at a distance r from the center, where r is the radius of the planet, right? If the value of g is given as, or the value of acceleration due to gravity is g, we can write with what force does the planet pull the object. So I'll take one student, let us take Atul. So Atul, with what force does the planet pull any object towards its center? Mg, right?
Gravitational mg, yes.
Mg is the weight of that body with which an object is pulled towards it.
Yes, sir.
So let us equate this to the force of gravitation being applied by the planet. So let's say the mass of the body is small m, radius is r, and the mass of the entire planet is capital R, right?
Yes,
So
sir.
gmm by r square will be equal to mg, correct? So what are we
Yes,
going
sir.
to get then? G is equal to
Equals to
gm
GM by R
by
square.
r square, right?
Yes, sir.
Now, since we know that g is the gravitational constant and m is the mass of the planet, we may or may not be knowing this value always, right? So it becomes very handy to substitute gm by small g r square, because most of the time we know that what is the value of g on the surface of the earth and the value of radius of the earth. So class, for your information, take this note that radius of the earth, right, r of the earth is nearly 6400 kilometers. Remember, this is kilometer, right? So this will be 6400 into 10 to the power 3, or you can write 6.4 into 10 to the power 6 meters. Class, take this note with you. Sometimes in the question this may not be given, they will expect you to know this value, right? So this is one, right? This is one aspect. So from here, you get, see, you get this dependence of G on R as inverse relation and dependence on square. So we have G is proportional to 1 by H square, right? Where H is the distance from the center of the earth, very important, or we'll better write this as R square. So let's say I take a body and now place it at some height. Let's say over here. Now this height is h above the ground. So now what you'll do, you'll write that g at this height, let's say that is g dash, that is acceleration due to gravity at some height, right? Upon g will now be given as in this same way h plus r square, because the height of this point, or let's say a, or its distance of the point A from the center of the earth is equal to h plus r, very clearly visible, right? I might write this now even in a more expressive term, right? So, or in a more expressive way. See here, class, we have, this is the distance r given, right? So there are several questions which are asked to you on such formats, right? Now there is a term called as gravitational field. Term is called as gravitational field. In this chapter there are some terms which have very similar meanings to what we already know, but when they are asked in the exam, students tend to get baffled, right? So it is important that you know these terms, right? That is why I'm introducing a term called gravitational field. Gravitational field is nothing but the force that is acting on the body, right, because of gravitation per unit mass of that body. Very simple. Force of gravitation per unit mass of that body, right? On this, let us solve the next question. So you have next question from JEE 2019. Let us take this question, right? So we have, all of you take down the question. Question says that a solid sphere of mass, class, take the question with you. A solid sphere of mass capital M and radius A is surrounded by a uniform concentric shell, is surrounded by a uniform concentric shell of thickness 2a and mass 2m, right? We are being told find out gravitational field find out gravitational field at a distance at a distance 3a from the center. So, class, before we proceed ahead with this question, there is one fact which I would like to tell you all and also take this as a note with you. Class, whenever we have spherical shells, that term is given, no? Do not baffle yourself. It's very simple to understand. See here. So let's say you're talking about two things. One is a solid planet, right? Whereas the other is a shell. Shell is nothing but a very thin layer of mud. You can think about it this way. We have a layer of mud, right? Which is all hollow. There is nothing inside. It's just called a shell. So suppose from the earth you take out all the mud, dig it out and throw it away and leave only a very thin layer of mud. So this will be called as spherical shell, whereas this will be called as a solid sphere. This will be a spherical shell, whereas this will be called as a solid sphere. Both will have their centers, both will have their masses. Now, I'll tell you a very important key fact which is going to help you in questions, right? So the key is, suppose I'm talking about a point, let's say A, which is over here. Suppose mass of both the shell and this solid sphere is same. Let us say mass is m. Let us say mass is m. Let us say their radius are also same. So this is r. We have same radius for the solid sphere and the spherical shell. Right. Now, the next point is, if both have same radius and same mass, what will be the value of force which will be acting on, suppose a boy, or let's say a mass here, which is m, kept on the surface of the two planets. One is shell while the other is sphere. The fundamentals say if the object is outside, class, take this as a note, if the object is outside pardon me, give me just 1 second. Yeah, so if the object is placed outside, let's say we are talking about mass m, then the entire planet, right, then planet behaves as a point mass, very important, point mass, which is kept at the center, which is kept at the center of the planet. Which is kept at the center of the planet. So all I mean is, suppose this is the mass, right, m. So this entire planet, be it in the solid sphere form or be it in the spherical shell form, this will act as if it's a small point mass of mass capital M and is placed at a distance r. Now it becomes very easy to find out gravitational force. It will be given as, on an obvious note, GMM by R square, right? And if I talk about gravitational field, how will you give it? We generally denote gravitational field by the letter E, by the letter E. Similarly, very similar to the way we denote electrostatic field, because you all have read electrostatics. We all know that uh, electrostatic field in class 12, right, is given as E. So we'll take on this also on a similar note. We have E is equal to force acting per unit mass and therefore Gm by R square. Right? This is the key fact that we should remember. Now, another fact about such distributions. Suppose this was the top of the point. I'll give the point a name. Let us say this was the top of the point A and for A dash, right? Now, let us say we are no longer talking about A and A dash. So this point was when the object is placed at A or A dash. Object at A or A dash. Now, second scenario. Let us say now no longer the object is inside, now it is coming. Now, no longer it is outside, now it is coming inside the planet. Very important. It's coming inside the planet. Now, we talk about object inside. That is at B or B dash. In case we're talking about solid sphere, it is B. In case we're talking about the spherical shell, it is B dash. Now let us draw what is the amount of mass that is inside the planet which is influencing this particle. I'll repeat class. I am trying to draw a circle keeping this at the radius. See, this point B as the radius, on the radius. See, here also. Right? So the key is now only the part between between the center of the planet and the object causes gravitational pull. What am I saying, class? I'll repeat. Now what happens is there are two parts, right? See here, there is one part which is outside this circle where this point is kept. That is this outside part, right? And the other is the part which is inside. That is this one. Now, the fact is that this part which I have shaded with yellow, that part has no role, or sorry, that part has only role in giving the gravitational force. So only the inside part gives gravitational pull. Gravitational pull. So what does this mean? The green part which I have shaded, the outside part, this one does not play or does not give gravitational pull to an object, gravitational pull to an object which is placed at the point B. Only the inside part gives the gravitational pull, not the outside. When are we saying this? When the object is now placed at a new position B. Only the part inside B as the radius, right? Inside this smaller radius will now have the gravitational pull, right? That is the key point, everyone. So this was the case about solid sphere. Now you can ask, sir, in this spherical shell, I can see that you just said that this is just nothing but a thin layer of mud. So here there is nothing, right? This part has nothing inside. So, sir, if this part has nothing inside, how will the force act on this object which is kept at B? Because there is nothing inside, no mass inside. Right? There is no mass inside. Then I will say that yes, Your guess is absolutely correct. When, so a sub point of this part, that an object is, when an object is inside a spherical shell, when an object is inside a spherical shell, no gravitational pull acts on it. No gravitational pull acts on it. Right? Super duper important point. I'll repeat my point, class. We understood that how when a mass is kept outside any shell or any solid sphere, entire shell or sphere behaves as a point mass, and the force of attraction is given by the same law which we know, gmm by r square, right? Newton's law of gravitation. But when we take this object inside, now we took this object from point A inside to the point B. Now we are saying that when it is kept at B, only the part which is inside B, that is this yellow color shaded part, contributes to the gravity, right? This outside part, the one which is shaded in green, this part has no impact on this object kept at the point B. Same analogy holds for spherical shell. Here also, when the object is placed at B, only the part inside it will have a gravitational pull. Since there is no mass inside here, this part, therefore there is no pull or no gravity acting on the object which is placed inside the spherical shell. That gave us the point A of the part 2. Right? Now, let us calculate how can we find out the value of force which is acting on this part after doing this question, right? Now, let us come back to the question and re-look at it. So, the question tells us, right? I'll draw the figure maybe on the next page. Or maybe, yeah, let's draw it over here. So the question tells us that a solid sphere of mass m and radius a is surrounded by a thin spherical shell of thickness 2a. Okay. So let's draw it here. We'll draw a solid sphere. Okay. Let's say this is a solid sphere. Okay. Which has, it is given in the question, thickness of radius a, right? So this radius a, thickness. Okay. Now let us take the next point. This was first point, right? It is surrounded by a thin uniform concentric shell of thickness 2a and mass 2m, right? So thickness 2a. Okay. So now we have a shell which is around it. So let's draw the shell. Right? Now the shell has a thickness of 2a, and it is around this given solid planet, okay, or solid sphere. So we have this as the shell, whereas here we have a solid sphere, okay. This is the solid sphere. What next? Let us read the next part. It says that find the gravitational field at a distance 3a from the center. Okay, 3a from the center. Let us see what are their masses. We have been given mass of this one is 2m, right? Mass of the central spherical solid is m, and now we are being told an object. Let me denote an object by this blue colored dot. Let's say I'm drawing the object over here. Okay. Now we have a blue colored dot telling me that there is an object which is kept at a distance 3a from the center. See, 3a. Okay. Pardon me. Yeah, this is 2a from the center. So let us make it at a distance 3a. See, let's take this one. Right. Okay, class, I'll try to validate what is given. So just rereading the question for all of you. Okay. So there is very tricky point hidden in the question. Class, we'll read it again. See, but before I move, I want you all to tell me if I have drawn everything correctly or not. Just give it a try. Only then I'll give my opinion on this. Yes. So now let us take any one of you. Let's take Ayush. Yes, Ayush. Ayush, can you just read the question and try to tell me if there is any glitch in the interpretation or the drawing of the diagram? Yes, Ayush. Or or am I correct always? Yes. Try it out. Yes, Ayush. I am there. In case you're wrong, also no worries. Yes, Ayush. Tell me. Are you there with us, Ayush? Yeah. My question is: are you able to look at the question and find out if there is any glitch in the diagram which I've drawn? Very important point which I'm going to bring to everyone's notice right now. Yeah. Anyone? Ayush, would you like to try? Yes, Samriddhi. You want to say something? Yes. Tell me.
Sir, it have been given that the thickness of the shell will be 2a.
Hmm.
So
Uh-huh.
the radius will be a, I think.
Thickness is 8. So therefore, we are being told, Samriddhi, you are very close to the right answer. See, we have been told that the thickness is 2a. See, this is given as 2a. This is called as, that is the distance between the shell and the inside solid part is called as thickness, right? So this is called as the thickness, and that value is given as 2a, not this green part or the radius. In the question, we are not being told that the radius of the concentric shell is 2a. Thickness has been told 2a. Whereas when would have been, when would have we drawn this? I'll just show here. Yeah. When would it be right, class? When would it be right to actually mark this radius as 2a? When would it would have been given that the radius is 2a, but the radius is not given 2a. In the question, we have been given that the thickness is 2a, right? So very close, Samriddhi, very close, right? I am actually very proud that you all are very close to understanding things on a better way, or in a very nice format now, right? Thank you, Samriddhi. Okay, so this distance has been given 2a. What does this imply, class? It implies that the distance from the center of this concentric shell is now 3a, not 2a. This distance is 3a because thickness is 2a. So 2a plus a gives me 3a, right? Now have a look at the question. It says find the gravitational field at a distance 3a from the center. Let's go for it. So we'll draw a small object here, right? For this object, we are being asked the gravitational field. We are being asked the gravitational field, right? So we'll have gravitational field, we all already know, given as gravitational field, or let's first find out the gravitational force, right? So gravitational force on the mass m is given as because of the sum of forces due to shell and sum of forces due to the solid object or the solid sphere, right? Let's say F2 and F1. So let's say this is because of the shell, whereas this second one is because of the solid sphere. So very easy. We know that the point is outside both of the periphery. So of course they will act like point masses kept at the center. So one by one we will have the values of forces as gmm, right? So mass for the shell is 2m. So I'll take this as g into 2m. Mass of the object is small m by the radius of this entire periphery is 3a whole square, right? Plus g times of, because of the solid sphere, again it will act like a point mass placed at the center. So we'll have g into, and its mass is small m. See, mass of the solid sphere is small m. So g into m, and the mass of the object is m upon its radius. So now we're not going to take a class. Why? Because this object m is placed at a distance 3a from the center. So again we'll have 3a here. Very important. It is very important to see that where is the object placed. The object is not placed over here, right? The object is not placed over here. The object is placed at a distance 3a from the solid sphere's center. I'll repeat, the object is placed at a distance 3a from the solid sphere's center. So that is why we will have the thickness as 3a also for the solid sphere, and therefore we'll have the answer as gmm by a square 2 by, in fact we can take 9 also here, 2 plus 1, which gives me 3, and therefore your answer is 3 by 9 gmm by a square, or gmm by 3a square is the value of force which will be experienced by the mass m, which is placed at a distance 3a from the center. But in the question we have to find out gravitational field, which will be equal to force experienced upon the mass of the body. So we will take force experienced whole by mass of the body, that is nothing but gmm up, upon m, right? And so this will become gm by 3a square, right? Gmm by 3a square whole by small m will give us gravitational field, which is experienced by this mass m, which is kept on the spherical shell. So class, if this application of the formula and the understanding of the question, if it's clear to you, please raise your hand. Yes, class. In case this entire question and the understanding of the formula is clear to you, please raise your hand. Yes, class. Okay, so I can see that you have raised hands. How about Harsh, Manjunath, and Siddharth? If there are any questions, one by one, we'll take. We'll start from Siddharth. Yes, Siddharth, go ahead. Any questions, Siddharth, you would like to put forward? Yes, go ahead, Siddharth. Okay, okay, all right, no worries, no worries. Uh, we have Manjunath. Manjunath, any questions? Just let me know, because your hands are not raised. That's why I'm asking. In case the question is clear, please raise your hand so that I'll know that it's clear. Otherwise, you can ask it out. Yes, class, go ahead. Okay. Siddharth, Manjunath, any queries? Okay. All right. No worries. So in case there are any queries, you can send them to me by chat, or you can also put your mics on and let me know. Yeah. Okay. If not, we'll go ahead, class. Everyone is clear? Thank you, class. You can bring your hands down. All right. Now, class, several questions are based on some other aspects of the three things we were taking, right? So here we took how the acceleration due to gravity is varying with height, right? We saw this as the formula. Take this with you. Similarly with depth, class, the variation of acceleration due to gravity with depth is given by, if it is at a depth d, right? So when I'm saying it's at a depth d, here it was at a height h. This was h. Whereas from the center, it was at a distance h plus r, right? Now, Now let's say body is inside this planet, and it is at a depth d, that is from the surface the distance is d. Now acceleration due to gravity at this new depth, let's say we take this as gd, is given by acceleration due to gravity at the surface, right, or g, we can take it as gs or g surface, times of 1 minus depth by r. Class, remember, when I'm saying depth, I mean distance from the surface. Very important. So when I'm saying depth, I mean distance from the surface. So here I'm talking about this distance. All right. This distance is d. Correct? Class, let us take some questions based on this aspect from the past year's paper. Right? I hope the formula has been noted by all. Please take the formula. Let's take some questions based on these aspects. Also, class, very clear. You all should be with these points. That third one, acceleration due to gravity. Suppose let us discuss it and then together take the questions. So let's say this is the planet. Okay, there are different latitudes. Okay, now class, every latitude is actually described in terms of the angle it is making with the center. I'll tell you how. So let's say now we have this planet. Let us make a latitude on it. Let's say these are different latitudes, right? I hope you all know that these are the horizontal, like they can be represented in terms of horizontal lines, but then there are circles around the sphere, right? Imaginary circles like Tropic of Capricorn, Tropic of Cancer. These are different latitudes around the sphere, right? So now, when I'm talking about variation of G with respect to a latitude, what I do is from the equator, like let's say this is the equator which is passing through the center. What I do, I draw an angle here, theta, right? Now on this latitude, if I want to find out what is the value of G and how is it varying, right? And let's say Earth is revolving about its center with an angular velocity omega, right? So I have G is equal to, right? G is equal to given by G at some given latitude, let's say G dash, let's say over here, it's G dash, right? So it is G, normal value of G, minus omega square, that is the angular velocity of the planet. What is angular velocity? Very simple. The angle covered by the planet per unit time. Very simple. Angle covered by the planet per unit time is called as angular velocity. As simple as that. The way we used to have normal velocity, right? Distance per unit time. Angular velocity is angle covered by Earth per unit time because it is revolving. Very important. The Earth is revolving, right? Now, G dash is given as G minus omega square into R, where R is the radius of the Earth, R is the radius of the Earth, times of cos square theta. This theta, this one. Yeah, I hope it's clear. So let's take a few questions based on this. So class, these questions were asked quite long back in, I think in 2002 or 2003. So again, these are very probable questions this year. Please take them up. Okay. So we'll have the questions one by one. Let's take the questions plus. So we have been given, take a note of the questions which are based on these concepts which we just read, right? So first question class, this is from AIEEE 2009. The question says, class, have a look, the height at which acceleration due to gravity becomes G by 9, where G is the acceleration due to gravity at the surface of the Earth. If this G represents the acceleration due to gravity at surface of the earth. Find out what is that height. We had to find out that height in terms of r. That height in terms of r as a function of r, where r is radius of the earth. Yes, class. You have been given with the options 2r. Option 2 is r by root 3. Option 3 is r by 2. Option D is root 2r. I'll repeat the question. We have been told that at a particular height, g is becoming 1/9 of itself. Find out what is that height. Very simple in terms of radius r. So let us take one of you for solving the question. Karuna. Yes, Karuna. Uh, can you try with, I'm there to help, don't worry, right? I'm there to help. So can you try telling me how does g vary with the center, distance from the center? Yes, Karuna. We just read, see here, distance from the center. Yeah, have a look. Tell me. Yeah,
D, sir.
yeah. Have a look. How does it vary? G with distance
1 by r square.
1 by r square, right? So now what are we supposed to find out, Karuna? That what is the height in terms of r, right? So,
R.
right? So now we are given, Karuna, that this is r, right? The radius. And from here, from the center, or in fact from the surface, the height is h. Am I correct, Karuna?
Yes, sir.
Now we are being told that at the surface, the value of acceleration due to gravity is g, and at this height it becomes g by 9, right? Correct?
Yes, sir. Yes, sir.
So, right. So how are we going to now find out? Now find out the height. So we'll write is proportional to g is proportional to 1 by r square. Correct? Correct?
Yes, sir.
What is the, now
Yes.
I'm drawing 2 points, Karuna. One is at the surface, let's say A, and the other is at a height h, let's say B. So now, how will you write the ratio of the two accelerations due to gravity? Let's say G dash is at height h, or we'll write it as GH only. Let's say G and subscript h upon G is telling us the ratio of the acceleration due to gravity at a height h upon G. How will we write this as? H plus r whole square, right? In the denominator. In
Yes.
the numerator, we'll have r square. Why? Because g is depending upon r square, and here gh is depending upon r plus h
R.
whole square,
Yes, sir.
right?
Yes, sir.
Okay. Now that we have this, how should we go ahead? Yeah, tell me. Do the substitutions. Tell me what will be substituted instead of gh?
1 by G by 9, sir.
G by 9 whole by G is equal to R by R plus H whole square. Am I correct in writing this,
Square.
Karuna? Yes, Karuna. Am I
Yes.
correct? Okay.
Yes. Yes, sir.
Now we'll write this as 1 by 9 is equal to, yes, tell me.
R square by R square plus H square plus 2RH.
This is one way. What about if the plan, Karuna, if I take root on both sides, tell me now what will be the answer? Yeah.
1 by 3 is equal to R by H plus R.
Doesn't it become easier, right? See,
Yes, sir.
by taking root on both sides, correct? Take
Yes, sir.
root on both sides. So now we have taken root on both sides, and now can we cross multiply, Karuna, and get the answer?
Yes, sir.
Tell me what should be the answer. H should be equal to
2R. 2R.
Yeah. Just go through the entire solution, Karuna. Let me know if our approach was correct. Just have a look at the question. So I'll narrate it for everybody. We were told to find out what is the value of height in terms of r if the object is kept at a height h, right? So we told that g is inversely proportional to the distance, square of distance from the center. So for an object which is placed at the distance equal to the radius, we'll have G inversely proportional to R square. And for an object which is placed at a distance H plus R, we'll have GH is inversely proportional to H plus R whole square. Are we correct in this formula? Karuna, have a look very closely. Are we correct?
Yes, sir.
Right. So now, is this calculation correct? Just go through it once and let me know if they are clear.
Correct, sir.
Absolutely correct. Okay, Ayush has also sent me the answer. He also had sent me 2 hour. I think he had sent the answer quite long back. Great, 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 Ayush. All right. All right, Karuna. Thank you, Karuna. Is it clear? Completely clear to you?
Yes, sir.
All right. Class, let's take the next question. Thank you, Karuna. Okay. So class, let's take the next question. You all have been given. The next question is, before taking the next question, I'll introduce you all to one more concept. Now, this concept forms such an important one to solve any question in this chapter that you all will be so happy that you all revised it before solving these questions. So see, there is something called as escape velocity, right? There is something called as escape velocity. The way we just read about orbital velocity is the velocity with which a planet is revolving around a planet. A satellite is revolving around the planet. In a similar manner, we have a term called as escape velocity. It is represented by the letter VE. Now, in the question, you may not always be asked to find out the value of VE. You should know one thing, like VO or orbital velocity was given as under root of GM by R or under root of GR, because we know the substitution now, right? That GM, we just had discovered this today, that GM is equal to GR square. By this substitution, we can write V orbital is under root of small g into R. In a similar way, escape velocity is given as 2gm by R, 2gm by R, and it is also given as under root 2gr. Now, what is escape velocity? Very simple. The velocity which will help any object escape the gravitational field of the Earth. I'll repeat, the velocity which will help any planet escape the gravitational field of the, or any object escape the gravitational field. Let's say this is the gravitational field, right, of this planet. So the point is, in physics, we say that the influence of gravity is still infinite distance. I'll repeat, influence of gravity is still infinite distance. The gravity force has range equal to infinity, right? Infinity means even if an object is very, very, very far away. Let's say we are talking about a galaxy called as Andromeda galaxy, which is millions and millions light years away from us, and even that Andromeda galaxy is actually pulling you towards it right now. Yes, I am very, very true. Even your let's say your copy or your pen is pulling me right now from my city, right? Why is this happening? Because although the gravitational force may be very weak, but its range is infinite. So we define a term called potential energy, which is called as, in better terms, gravitational potential energy. Class, gravitational potential energy, which is given by minus GMM by GMM by X, where what is small m? Of course, mass of the body. Capital M is mass of the planet, and this X is called as the distance between, again, the center of the two, that is object and the body. Plus, for a satellite, there are some other key points also which become important, right? So for a satellite, this velocity of, or this gravitational potential energy is given as minus GMM by, let's say if this distance between the satellite and the Earth is capital R, then minus GMM by R, or it's even better if we denote it by the letter small r. Let's say this is small r, okay? So now we have minus GMM by R is the, of course, it's potential energy. Kinetic energy is half m V naught square. What did we get V naught? We got V naught as Gm by R under root. So its square will be Gm by R. So we have kinetic energy of a satellite is Gmm by 2R. See, this is how we have derived kinetic energy, right? We derived kinetic energy. Now, class, can anyone tell me how will you find out the total mechanical energy? It is important to understand that total mechanical energy is nothing but the sum of kinetic and potential energy. So sum these two. What do you get? See, minus GMM by R, or potential energy, plus GMM by 2R, that is kinetic energy. What does it yield you? It yields you minus GMM by 2R. Okay, I can see that the total mechanical energy of a satellite is negative. Yes, it is negative. Yes, it is negative. Class, have a look here once again. The total energy of a satellite coming negative is actually telling you the fact that there is some kind of attractive force acting on the body. Class, take it as a note with you. Whenever an attractive force is acting on a body, right, and making it revolve around any other body, then the net energy of the body will be negative. Class, the total energy of the satellite is coming negative because an attractive pull of the planet is acting on it. Please take this as a note with you, because the pull of the planet is working on it, right? So this is how we got U is equal to minus GMM by X, K is equal to GMM upon 2X, right? Now class, we'll have some questions based on this, or you can also simply take this as half mv square. It's even better. So this was only for the case of a satellite, but not always true. So now I'll try to rather rub this, and we'll take for a general definition. We'll take a general definition, right? Half mv square. Now let's solve some questions based on this, right? Let's solve some questions based on this. So class, take your question. The question says, we are taking one by one different kind of questions, class, right? So class, one thing, I would like to number the question, some which I taken. Yeah, this one, the first question which we learned, no, such questions were asked in the year, I'll tell you, it was asked in the year AIEEE 2004. The first question which we just discussed, right? That was from AIEEE 2004. This one, the dependence of the dependence of orbital velocity and time period on the radius if the force no longer depends upon 1 by r square but 1 by r power n, right? Such question was asked in AIEEE 2004. Now let us take more questions based on the application of such substitutions of energy. So yes, just a minute class, I am giving you all the question. Okay, great. Take this question from JEE Main 2019 again. We have the question as a satellite is moving with a constant speed v. There is a satellite which is moving with a constant speed. Remember, it's not saying velocity, it's talking about speed. A satellite is moving with a constant speed v around the earth, right? An object of mass m is ejected from the satellite. An object of mass m is ejected from the satellite is ejected from the satellite such that it escapes from the gravitational pull of the Earth. It's given such that it escapes gravitational pull of the Earth. Now, at the time of ejection, we are being told find out the kinetic energy. At the time of ejection, find out the kinetic energy. I'll repeat, class. We are being told that an object of mass m, this is the satellite which is shown. Let's say at the center you have Earth. Let's say Earth, the blue planet is at the center, right? From here, around it, a satellite is revolving, the one black in color. From this, a small object, let's make it in red in color. So a small object escapes the gravitational field and goes into infinity. Remember what did I told you? What did I tell you just some time back? That the range of gravity is infinity. So whenever we are told that something escapes the range of gravity, it means that it goes to a place where r from the center of the planet is infinity. This is called escaping. Very important. This diagram is not given in the question, class. I am drawing it for your convenience. I'll repeat. When anything escapes away from the field, always take r as infinity. Very important, right? The final value of distance of this planet from the Earth is, if that is given by small r, its value is infinity, because until infinity there is range, right, of that gravitational force. Okay, so can anyone help me with this question? Let us now take Harsh. Harsh, is your mic working? In case yes, just can you help me with this? Yes, Harsh. Harsh, you there? Okay, no worries, no worries. Let's take Mahila. Okay, no worries, Harsh. That's all right. Okay, no worries. Mahila. Yes, Mahila. I'll be there with you. Don't worry. One by one, let's solve it. So,
Yes, sir.
okay. So, Mahila, we just read an equation. See here, that what is the value of total mechanical energy? Read the statement. Total mechanical energy is given as,
K plus U is equal to
yeah. So what does
G.
this mean? What does this mean, Mahila? What is K? What is K?
Sir, K represents the kinetic energy, sir.
And U represents the
Initial
Potential.
potential
gravitational
energy.
potential energy. What does this represent, Mahila? Gravitational potential
Potential
energy,
energy.
right? So this is
Yes, sir.
gravitational potential energy,
Potential energy.
and this is kinetic energy. See, we can see here, right? Half
Energy.
mc square, correct? Now,
Yes, sir. Yes, sir.
now let us take in this question, what are we being told? We are being told at the time of ejection of the mass. So what is happening? I'll tell it to you once again. Mahila, there is a satellite, okay, which is revolving the Earth. The
Yes, sir.
center there is Earth. Now satellite is revolving this Earth, correct? Now
Yes, sir. Yes, sir.
let's say the mass of the Earth is capital M. Okay. Now what happens is, at
Yes,
some point of time, suddenly a small mass M comes out from the satellite and goes into the space. And goes into the space. Now we are being told,
Space.
find out what is the kinetic energy of that mass
Escaped on.
when it escaped. Correct. Correct.
Yes, sir.
So that means there should be definitely some kinetic energy that has to be given to the object so that it can escape. Now this entire force,
Yes,
Mahila,
sir.
is gravitational force. What kind
Yes,
of
sir.
force is gravitation, Mahila? Conservative or non-conservative?
It's conservative force, sir.
What does conservative mean? What is conserved? Why is it called conservative force? What is conserved?
Because Because
Because
it conserves
total
force,
mechanical energy is conserved. It does not conserve
energy
force.
conserved.
It does not conserve
It
force.
conserves total
Yeah,
mechanical
just listen.
energy,
Yeah,
sir.
just listen. One minute. So what are we saying? It is a conservative force, not because it conserves some kind of force. No, it is called a conservative force because when a body, take this note with you, Mahila, when a body is
Yes, sir.
under the influence of, is under the influence of, is under the influence of gravitational force, when a body is under the influence of gravitational force, its total mechanical energy is conserved. Write this,
Energy is conserved.
total, write it with you. Its total
Yes,
mechanical
sir.
energy is conserved. Did we study this before, Mahila?
Yes, sir. We studied,
Yeah.
sir.
So you should remember, okay? Now don't forget this
Yes,
because
sir.
it's
Yes,
a
sir.
very, very crucial point. And class, I'll repeat once again. If you all are not revising whatever we kind of questions we solve in class, the classes will actually become futile. Unless you revise, nothing is going to settle. Very important, right? So please revise in case you're not class. Okay. So let's, Mahila, continue this question. We'll have total mechanical energies conserved. This means that the sum of kinetic and potential energy should remain constant. Should remain constant, right? So we'll have initial kinetic energy and initial potential energy is equal to the sum of final potential energy and final kinetic
Energy
energy,
and final
right?
kinetic energy.
Now, what is the formula for
Yes, sir.
potential energy? See this and tell me. Yeah, tell me. U is equal.
Sir, it's minus G.
Tell me.
U
U
is
is
equal
equal
to minus GM by
mm by
minus
x.
GM by X.
GMM by
Minus X.
minus
X.
GMM by x.
MM
Right?
by X.
What is x here? See here in the diagram and tell me what is x. X is the
X is the exerted force.
x is not the force.
Center, sir.
X is the distance between
Center.
the center. Yeah. Just listen to me.
Between mass and
Yes, I'll repeat once again for your convenience. Yeah. So x is the
yes.
distance between the planet and the small mass m. I think there is somebody with near you who is talking. So one request, class. In case you are in your vicinity, there is anybody, please either ask them to be very silent or go to a place in your room wherever you can study with full focus, right? So because that actually interrupts the normal working of the class, just a gentle request, right? So let's continue. So Mahila, we have what is x? X is the distance between the mass m and the planet
The
center
center
of the
and the
planet,
mass.
right? This is x, and m
Yes,
and
sir.
capital M are the masses of the satellite and the planet, right? Or the object which under consideration.
Yes, sir.
Now,
Yes, sir.
now we have this Q. Now we have this Q is given as minus initial when it is over here. So let's say its distance or the radius of the path in which the planet is revolving is x r. So instead of x we can write r, right? So we'll have minus gmm by r,
R.
where small m is the mass of
R.
the earth. Correct? Correct?
Yes,
Right?
sir.
Now,
Yes, sir. Yes, sir.
now we give some kinetic energy to it. Let's say ki. We want to find out what is this kinetic energy, right? In the question, we are being told what is
Yes,
the
sir.
kinetic energy when the object is over here. So what are we doing, Mahila, in this question? In this question, like other questions in the past, we are taking kinetic energy here plus potential energy over here itself. Their sum should be kinetic
Yes,
energy
sir.
at the infinity and the potential energy at the infinity. Are we clear, Mahila?
Yes, sir.
Okay.
Yes.
So
Yes,
now,
sir.
instead of UF, we will write minus GMM upon.
GM by.
What is the distance now? What is value of R? See here and tell me. Value of R is
It's infinity, sir.
infinity. Why is it
Infinity.
infinity? Why is it infinity?
Because we don't know the actual value and R is always equal to infinity.
No, R is not always infinity. Here we are being told that the planet is going far away and escaping the field. Just listen.
Yes,
Just listen.
yes, sir. Yes, sir.
One minute, just listen. I am saying that the planet, this small mass m, is going far away from the gravitational field of this planet. The small mass m is escaping the field, and the field extends till infinity. So when I'm saying infinity, no, do not take it as something rocket science. Infinity means just a very, very large distance. So if from the center of the planet, if something goes to a very large distance, I'm just saying, let us take that large distance is equal to r is equal to infinity. Am I clear now?
Yes, sir.
Okay.
Yes, sir.
Now we assume it goes there and stops. What are we assuming? It goes there and stops. So if
Stops.
it stops, will it have some velocity, Mahila?
Yes, sir. It will, sir.
No. When anybody stops,
Yeah,
or when
yeah.
anybody is
It
at
will
rest,
not have, sir.
when anybody, listen, when anybody stops or when it is at rest, its velocity is equal to, tell me, it's equal to
Zero.
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 Absolutely correct, right? So at these small points we need to improve, right? So this v becomes zero. We are assuming, now understand the situation, Mahila. What is happening? A small mass m is going from this satellite into interstellar space. There, the value of r is becoming very large. We are taking that r is equal to infinity, and at that point, the object goes and stops. The object goes and stops. Because the object is
Stop.
stopping there, at that point, the speed has become how much? Zero. Right?
Zero.
Right. So we'll
Yes,
have this term. Acha, anything upon infinity, how much does it become, Mahila? Anything upon infinity is equal to
zero.
zero. Absolutely correct. So we'll have 0 is equal to Ki minus Gmm by R, right? This will give us,
Yes, sir.
this will give us Ki is equal to Gmm upon R, right? Where R is the distance
Yes.
from the center. Now, in the question, R was not given. In the question, R was not given. R is something what I assume. In the question, all you are given with is M and V. M and V. Now you need to convert this expression in terms of M and V, where what is V? V is the orbital speed. What did we read the orbital speed as? Tell me, under root of Gm by R, right?
Yes, sir.
Now we have under root of Gm by R is speed V. Now we have to convert this from here into terms of V. So let us write from here, V square is equal to Gm by R. Can we write it this
By
way,
R.
Mila?
Yes, sir.
Right. So how can we substitute it here? Substitute and tell me what should be the answer? The kinetic energy in terms of V square. Yes, tell me. Substitute it here. Just do the substitution, nothing else.
Sir, it's
Yeah. Tell me.
V squared M.
Very good, very good. So we have V square into M given as the value of kinetic energy. So the interpretation is when this satellite was revolving, I threw this small mass M, I threw this small mass M with a kinetic energy of mv square, kinetic energy which has a magnitude mv square, where v is not the velocity of that object, rather v is the orbital velocity of the satellite, right? So with this, I flew the object and the object went into the interstellar space at a very, very large distance, such that there it goes and stops. Since it stops, here its kinetic energy, final kinetic energy is zero, and its potential energy is minus gmm r upon r, where r is infinity. Anything upon infinity gives you zero, and therefore we got the answer that initial kinetic energy of that object was mv square. Is it now clear? Sure?
Yes, sir.
Sure?
Yes, sir.
Okay.
Yes, sir.
All right. Thank you, Mahila. Great. Also, Mahila, don't get discouraged in case you give any answer wrong. It's very good. It's okay to be wrong, right? It's okay to be wrong. When
Yes, sir.
we are
Yes,
wrong,
sir.
we are actually learning, right? So today you will remember this day because you have learned something new. Am I correct?
Yes, sir. Yes, sir.
Okay, great. Thank you. Thank you, Mahila, for your sportive nature and thank you for participating. Great.
Yes, sir.
All right. So let us take the next question, class. This is also very important. And in every year's JEE, you're asked one or the other question based on the concept of density, class. Based on the concept of density. Let us take this question. Have a look, everyone. Take a note or the question basically. The question is from JEE 2019 again. The question says that the ratio of weights on a body on the earth's surface, so that on the surface of a planet, that means ratio of weight on the earth and the ratio and the weight on the surface of a planet. This ratio is given to us as 9/4. Okay, now we are told that the mass of the planet is equal to 1/9 of the mass of the earth. 1/9 of the mass of the earth. This is given. We are told that if r is the radius of the earth, r is radius of the earth, if r is the radius of the earth, what is the radius of the planet? This is what is asked. Class, let me tell you, whenever you have such questions, again, it is very easy. Have this point of view in the mind. It's given in the question that planet both planet and the earth have same density. It's given that both planet and the earth have same density. Class, remember this one thing in your mind. Always write what is given to you. Always write what has to be found. So in our case, we have to find out radius of the planet. This is to be found, right? This is to be found. What is given is all the data I've written here. That is the ratio of weights on the earth and on the planet, the relation between mass of the planet and mass of the earth, right? And also next data. So 3 points are given. This is point number 1, point number 2, and third point, the density of the planet and the earth are same. We have to find out what is the radius of that planet. Very simple. All your answers will stem from just one definition. If you know what does density mean, very important. If you know what is the relation between gm and gr square, which we had just read some time back, just from this relation, everything will come. So can somebody try? Siddharth, can you try and tell us the approach? How should you go about the question? Yes, Siddharth, get going. Yes, Siddharth. You can try. I am there with you. No worries. Anyone else? Siddharth, are you there? Okay, Ayush, would you like to try? Yes, Ayush.
Yes, sir.
Yeah, can you try? How should we go about it? I am there with you. If at all you go wrong, no worries. Yeah, but I hope and I'm very sure you'll be able to do it. Yeah, tell me.
Yes, sir. Actually, we are given the weight of Earth by weight of planet.
Right.
Sir, we will equate it by 9/4 g of Earth upon g of planet.
Absolutely correct. So see here, class, Ayush has told a very good point that how did he write the ratio of weights is equal to ratio of G? Because we know that W is equal to mg. So we'll substitute instead of W of the object, that is the weight of the object on Earth, will be its mass into its acceleration due to gravity on Earth, and that on the planet is equal to mass into acceleration due to gravity on that planet, right? So we get this value, m and m get cancelled. We have 9/4 is the ratio of acceleration due to gravity. Good. Yes. Tell me what's the next thing?
And so we know that small g is equals to g capital M by r square. So
So we'll write
we will
GM.
substitute the values of g Earth and g planet.
Absolutely correct. Absolutely correct. See, so Ayush has told us that we can take G. This G is a constant. We know it's called This G is called as gravitational constant. So we can write for any two given planets, gr square upon m is a constant. Class, what I'm writing, just take this as a very important keynote because every year some or the other question might pop up in this aspect. Gr square by m is a constant for any two given planets. Take this note, class, where what is G? This G is acceleration due to gravity, acceleration due to gravity on the surface. This is mass of the planet. This is radius of the planet. Now, yes, Ayush, substitute the values. So we get
Yes, sir.
G by
Uh,
G into R square. I'll just write it for you first. G by R square whole GR square whole by M for the Earth will be equal to GR square whole by M of the planet. Yes, Ayush, go ahead.
so actually, I just equated the equation. So 9 by 4 is equals to gm of Earth.
So we'll write, let's do it, GE by GP. So we'll take, this is GE, right? Times of
Yes, sir.
RE square whole by ME. Let's take EEE as the substitutes or the uh, subscripts for Earth and PPP for, as the substitutes for the
Planet.
values for planet. Absolutely correct, right? So class, we'll have therefore GE by GP. We know this value, right? GE
Yes, sir.
by GP. Then let's arrange one more thing. We know the value of MP upon ME. See from here, class, M of
1
the
by 9,
planet
sir.
upon M of the Earth is equal to 1 by 9. Just Ayush, cross check it once. Are we correct?
Yes, sir.
Okay.
Yes, sir.
Okay. So we'll write MP upon ME. Okay. Let's take that term here. MP upon ME. So class, what I'm doing is I'm just arranging these equations in the way such that whichever values are given to us will exactly fit in there. So class, see here, we had been given in the question, mass of the planet is to mass of the Earth is 1 by 9. We'll substitute that to get 1 by 9 here, right? And Ayush is telling me that we can take GE upon GP from here as 9 by 4. Let us do that.
9 by 4, sir.
Right. So we'll take this as 9 by 4 is equal to RP upon RE, that is radius of the planet upon radius of the Earth whole square. We'll cancel the 9 values. We'll get R of the planet, radius of the planet by radius of the Earth is equal to 1 by 4 under root, which gives us 1 by 2.
1
Correct?
by 2.
Correct. So we'll have
Yes,
radius
sir.
of the planet is equal to radius of Earth or R upon 2.
2.
Right? Ayush, once cross check it, let me know how did we do it.
Sir, it's correct, sir.
Yeah.
It's correct.
Okay. Can in one line you can just narrate the entire question, what was given and what did we found in just 1 or 2 lines? Yes. Yes. Go ahead, Ayush.
But actually, we were having the weight of Earth by weight of planet, and that was 9 by 4.
Uh-huh.
And so mass of planet was 1/9 the mass of Earth.
Mm-hmm.
And so we were asked to found the relation between the radius of planet and radius of Earth.
Right.
We just use the weight equation, small g is equals to g capital M by R square,
Uh-huh.
and we substituted the values of small acceleration due to gravity of Earth
Right.
by planet,
Right.
and so we got the relationship between them.
Absolutely correct. Absolutely correct. Great. Thank you, Ayush. Class, if this question is clear to all of you, please raise your hand. We'll just do one more variety of question. So these were all the varieties of questions which are generally asked in your examinations, right? Which are asked in examinations. We'll take one more variety to complete the variety of questions. I'll send you all the assignments like always. You all have to solve it, and we'll in the next class we're going to discuss. Yeah. So I'll have hand raised from everyone who has understood this question. Okay. Karuna, are you clear? In case yes, please raise your hand. Or in case not, you may ask your doubt. Yes, Karuna. Yes, Siddharth. Anything to ask? Tell me. Yes, Siddharth. Okay. You can message me in case there is any question, Siddharth. Okay. All right, class. Thank you, everyone. You can bring your hands down. Let us take one more final variety of question, class, which is based on differentiation and integration. Now, here is what comes the importance of the differentiation and integration application. All right. So class, this actually forms really important part of the chapter, right? Apart from this, there are Kepler's law, which are given in the question, right? I'll be giving you some assignment questions, which will have the application of the same. So need not fear. Try solving those questions, right? We'll be having a discussion of them in the coming class. So before that, we'll have the discussion of integration and differentiation based problems from gravity, right? So let us take those questions. Just a minute. Yeah. So let's say class, you have been given this. So this was also asked in your examination, right? This is a question. This question was asked in the year JEE 2019, right? So I'll try not giving you the exact same question, but I will give you a question which is based on it. I will read out the question, right? You have a rod. You have a rod. Let's say rod is given of the length L. Rod is given of the length L. Okay. It said that it extends from x is equal to a. It extends from x is equal to a. So suppose we have something called as x-axis over here. So let's have, this is y-axis, right? And now let me draw with blue x-axis. So this rod has been now kept on x-axis. It is being told that this rod begins from a point x is equal to a and ends at the point x is equal to a plus L, such that its length is equal to L. Okay, such that its length is equal to L. This is what is given in the question. Okay. After this, you have been told that the gravitational force which it will exert, class, I'm repeating my question, gravitational force exerted by the rod on a point mass m, on a mass or a point mass m at origin or at the point x is equal to 0 is given by what formula? The force F is given by what formula, right? So we'll take a particle small of a point mass. This is a point mass over here, right? I'll draw it even better. So let's say we'll draw it with red. The point mass is placed at the origin. Now see, this is how the point mass is placed. So class, we can have one observation from here, that whatever questions we have read until now, wherever the mass is, right, wherever the mass is, it is always almost at an equal distance from the center, or there was this uniform symmetry in those questions. But here that is no longer there. Now every part of this rod is at a different distance from this mass, right? Am I correct, class? I'll repeat. Every mass, every element mass is at a different distance from this mass small m, right? Right? And now how will you find out the total gravitational force because of all of these elementary masses of the rod, In the question, you have been given one additional data. You have been told that the mass of the mass in the rod is not uniformly distributed. I'll repeat, the mass in the rod is not uniformly distributed. It is distributed by this equation. See here, class, the mass per unit length, it is given this way in the question. The mass per unit length, some people call it as linear mass density. Some people call this as linear mass density. or mass per unit length of the rod is given by P plus QX. P plus QX. This is how the mass per unit length is given. You have to now find out what is the net force which is acting because of this rod on the small mass m. Right? How should you go about it? So, can anyone help me? Let's take the help of Manjunath. I'm there. Don't worry. Yes, Manjunath. Try it out. How should you find it? Here, no, Manjunath, we'll repeat the same panda which we had repeated the last time. Whenever you have integration differentiation, you take the sums, you take similar variables to one side, then you integrate, then you apply the integrate on both sides, apply limits, and then proceed. That is what is going to come, right? That is your hint. Now try it out. Yes, Manjunath. And
So we
I'm
will
sure
use
you'll
the
be able
formula.
to do it. Yeah. Tell me.
So we will use the formula of the F is equals to the formula of force F is equals to K m1 m2 by r square.
Right. So tell me one thing, Manjunath, is so all the elements. So let's say if I split this rod into several elements, which I'm drawing right now, are all of those elements at same distance from this mass, or all of them are at different distances? Different distances,
So
right?
they are at different distance.
Right. So if
Yes, sir.
they are at different distances, the force due to them, we know, should be inversely proportional to the distance between the masses, right? So the force should also be
Yes, sir.
varying for each one of them, correct?
Yes, sir.
So for such a scenario, Manjunath, we utilize the concept of integration. Whenever there is continuous distribution of mass, I will repeat, whenever there is continuous distribution of mass, we utilize the concept of integration. See how? So we will take, let's say there is some mass, dm, right, inside this rod, which is at a distance of x from the origin. Okay, and at the origin, coincidentally, we have small mass m. Right now, can we find out? Let's for our convenience, we'll take this small mass as m naught. Okay, so now can we find out what is the elementary force? So class, what is this? This is elementary force. Elementary force of gravitation between m naught and dm. Yeah, tell me, how should we go about? Yes, Manjunath.
So as we know that force is inversely proportional to distance
Yeah,
square.
yeah,
So there G and the M are like we can take them as the constant.
right. So see, Manjunath, in case we have two objects, right, of masses m1 and m2, how should we give the force? gmm by r square. This is the
Yes, sir.
gravitational force, right? Now I'm talking about gravitational force between masses dm and m naught. How would you give it? As g times of m naught into
M naught and dm
dm whole by, what is the distance between them?
x square.
Distance between them is x, and therefore the denominator will be x square. Absolutely correct.
X square.
Right? Now, let us have a look
Yes,
at this equation, Manjuna. What is it given? Mass per unit length or something else? Mass per unit
sir.
length.
Mass per unit length.
Then let's say this mass dm has a length of dx. How much, Manjuna? Dx. Right?
Dx.
So we can have in the question lambda is equal to mass, that is dm, per unit length, that is dx, is given as p plus qx. Correct? Now,
Yes,
what
sir.
will we do? Instead of this dm, what can I write? P plus qx into dx. Yes or no?
Yes,
Right?
sir.
Where in this equation? In this equation. Because what are we supposed to find out? We are supposed to find out total force. We are supposed to find out total force because of this rod. What I know right now is just the force because of this particular dm mass. I'll repeat. Right now what we know is just this particular force df because of this mass dm. Now I want to find out what is the total force f acting because of the rod. Right, Manjunath? Am I clear with my statement?
Yes. Yes, sir.
Okay. So in order to find that total force, I know one thing in mind. What is that one thing? I know that total force F should be integration of df, right? Right?
Yes, sir.
So now, first of all, let us write what that df is. We have df in this, we had it as g m naught into dm by x square, and then we could write this as g m naught instead of dm. What can we write, Manjunath? Tell me.
So P plus QX into DX.
Right. Why did we do this? We did this because now we have x square in the denominator and dx. Here we had dm and x. It was not integrable, but now this expression becomes integrable, right? Correct?
Yes, sir.
So now
Yes,
we
sir.
will have gm naught, right, times of p by x square plus qx by x square, that is q by x, correct? Q by x whole
Yes.
into dx is the value of df. Am I clear until this point, Manjunath? I've just done the
Yes, sir.
substitution and find it out. Oh, sorry, and found out what have I found out? I have found out what will be the elementary force df acting because of this small mass, because of this small mass dm. What is the elementary force df acting on this mass m naught? Am I clear until this point, Manjunath?
Yes,
Right?
sir.
Okay. So now in the question, we are supposed to find out the total force acting. So all we are going to do is integrate this force and get the answer. So we will write, everyone concentrate. We will have net force or total force is integration of df. We just got df as g m naught into p upon x square
P by
plus
X.
q by x sines of dx, right? What is the limit of the
Yes.
rod? From where is the rod extending? Yes, tell me, Manjunath. X is
So
equal
from
to
X is
A,
equals to A to X is
X
equals to
is
A plus
equal
L.
to A plus L. Absolutely correct. So tell me the limits of X here, Manjunath. X is equal to A.
So A to A plus L.
Absolutely correct. Let's integrate it. So can you tell me what is the integration of P by X square, Manjunath? We can take P common because it's outside the integral. And for 1 by x square,
Yes,
we can write it as 1 power x power minus 2, right? And we already know
yes,
that integration of x power n dx is given by x power n plus 1 upon n plus 1, right, Manjunath?
yes,
So
yes, sir.
similarly, for integration of x power minus 2 will give me in x power minus 2
So
plus
minus
1,
P by X.
yes, upon minus 2 plus 1, right?
Yes,
Correct?
sir.
Now, what is the integration of 1 by x, Manjunath?
So we have to
Log of x.
apply log there.
Yes, absolutely correct. So this will be log of x. Very good, Manjunath. Right? Now let us write this gm naught times of minus p by x plus q times log of x. Am I clear until here, Manjunath?
Yes, yes, sir.
Now let us take the limits from a to a plus l, correct? So when I take the limit
Yes, sir.
a plus l, instead of x, I will substitute a plus l, right? And when I
A
take the
plus L.
limit as x is equal to a, so instead of x, I'll substitute a in both terms and then subtract these two values, right? So let us do that. Let's take gm naught common. We'll have minus p by, first of all, instead of x, you will write, tell me, Manjunath, a plus l,
A
right?
plus L.
Right. Then plus q times of
Plus
log of
Q
a plus l,
L
right?
A plus L.
Now this entire
Yes, sir.
term minus the entire term
Minus
using x is equal to a. So we'll have minus p by a plus
P by A
q
plus
times of
Q L in A.
log of a. Very good, Manjunath. So is the answer and the way we have approached clear to you, Manjuna? Is it clear until here?
Yes,
Right?
yes, sir. It's
So
clear, sir.
now all we have to do is just some algebraic play of words or algebraic play of some formula. So we have minus p upon a plus l, right? Plus of, see this minus and this minus will become plus.
So they get
So
plus, sir.
plus of p by a
P by A
plus q common, right?
plus
Or
Q.
q times
Yes,
of
sir.
ln of a plus l minus
A
ln
plus
of
L.
a, right?
Yes,
Right,
sir.
Manjuna? Okay. Now,
Yes, sir. We can further write it as
yeah, we all know the formula that log of a minus log of b
minus log
is given as log of a by b.
log
You
A
all
by
know this
B.
formula? Right. So we'll
Yes, sir.
have this entire term given by gm naught. Let's take p common. We'll have 1 by a minus 1 by a plus l whole plus q times of log of a plus l
Log of A plus L by
upon
A.
a, right? Because two terms in
Yes,
log subtracted give us the division uh, expression, right? So we can take denominator a times of a plus l.
yes, sir. So L plus L minus 1
So l
numerator.
plus a minus a, correct?
Yes, sir.
Into p is equal to q times of 1 plus l by a, right? Right, Manjuna?
Yes, sir.
This is just
Yes, sir.
mathematical play, no worries. So you will basically, how you'll write the answer depends upon how you need to arrange it according to the options given in the question, right?
Yes, sir.
So I believe approach is clear. All we have done is just uh, calculated the value of calculated the value of elementary force df and then integrated it throughout the rod length, right, Manjuna? This is what we did.
Yes, sir.
Okay, so I'll write this L upon L plus A into P whole plus Q times of ln of 1 plus L by A, right? Is this the value, final value? What is this, Manjuna? This is the net force, which is
Net force
acting by
at
the
the
rod on this
origin.
mass M, right?
Yes,
Correct?
sir.
Okay. So now for Manjunath, for the convenience of everybody, can you once repeat this? Just give me a minute. So just a minute. So we started from here, right? We took different kind of very special formulas and took their application into account, and then we discussed questions from the past years, and I'm pretty sure that all of you have understood this very well, and that now whenever such kind of questions will be asked, you all will be able to tackle it very gracefully. So okay, yeah, Manjuna, just explain this question in 1 or 2 lines. What was asked and what was our approach in solving it? Yes, Manjuna, go ahead.
Okay. So as we know that in this question, we know that the rod was rod was in the horizontal position. So
Uh-huh,
there would be we were asked to find the force acting on the mass m, which is at the origin
uh-huh.
by the rod. So as we know that the different different pieces of the rod will have the different force on the particular mass which we need to find.
Why will they have different distance? Why will they have different force?
So they will have different force because of their different distance, sir.
Because every part of the rod is at a different distance from this mass. And we know that the
Yes,
gravitational
sir.
force depends upon the distance. And therefore, each part will exert a different force. And this is continuous distribution of mass. What is it, Manjunath? This is continuous distribution of mass.
Continuous. Okay,
Right? It is
continuous
not a
distribution.
it is not a discrete distribution. Had it been a discrete distribution, we would have done the same thing with that we did in the shell and mass question. Remember this first question that we
Yes,
did,
sir.
where this mass was kept here, we had just added the force, right? See, here also we had one shell, and we had one solid sphere, right? One
Yes,
shell
sir.
and the one solid sphere. We were asked the total force on this mass. We could have integrated, but we did not integrate. Why? because this was the case of discrete bodies. This was the case of discrete bodies. But are these bodies discrete now? No. These elements are now in continuum with each other. They are in continuum with each other, or we call this as continuous distribution of mass. Right, Manjunath? Is it clear?
Yes, yes, sir.
So whenever there is continuous distribution of mass, we have to learn that, we have to understand. Yeah, continue with your explanation. Yeah, you're going very correct. Yes, go ahead.
As we know that there is continuous distribution of the mass, so
Mm-hmm.
first we need to find the force acted by the rod at a particular, like at a small part. So we will take the small part as the dm,
Mm-hmm. Mm-hmm.
as we have the two masses now, one at the mass which we need to find like one the mass which is given to us, and the mass which you have taken the small mass.
Mm-hmm.
And now we used to now we will use the integration, as we know that the position of the rod is given at x is equals to a, and the x is equals to a plus l.
Right. So I'll just
We
stop
will use,
Manjunath 1 minute. So class, Manjunath is saying that we are doing whatever we used to do in simple scenario also. We used to be given that there are two masses. So here also we have two masses, dm and m naught. So Manjunath is saying just what we used to do. There is nothing different. Almost similar to what you used to do. Just that now we have a dm mass. So now what is the value of this dm came from what is given in the question. We were told that mass per unit length is p plus qx. So Manjunath is saying that we can take dm as p plus qx and then put this in the equation. After putting this, we know that from where to where is this mass extending, this continuous mass. It is extending from x is equal to a to x is equal to a plus l, and therefore we are substituting that as limits. Yes, Manjunath, go ahead.
yes, the same only, sir. As we know
Right.
that in the question, as it is given that the mass per unit length is given
Mm-hmm.
as lambda is, as we know that the lambda or the mass per unit length value is given as p plus qx.
Right, right. So
Further use it to find the value of dm.
yeah, so class, we were given that this lambda, it was given in the question as p plus qx, and therefore we just substituted that lambda or the value here, because we know that from here dm is equal to lambda dx, right? And the value of lambda or mass per unit length was given. We substituted it, found the answer, and got net force is equal to gm naught times of pl upon a plus l plus q times of ln 1 plus l by, right, Manjunath? Is it clear to you, Manjunath, the entire approach?
Yes, sir.
All right. Class, in case the entire approach of solving this question and the question itself is clear to you, please raise your hand. Yes, class. Please raise your hand to the question and its solving strategy is clear to you. Okay, so I can see that the question is clear to everyone. Thank you all, right? Thank you everyone. In the next class or in the questions which I'm going to give you, I'm going to give you questions based on gravitational potential. Class, what is gravitational potential? In brief, I'll tell you. Gravitational potential is nothing but potential energy per unit mass. See, today we learned what is called gravitational field. Field was force per unit mass, gravitational force per unit mass. So similarly, potential is nothing but and gravitational potential energy per unit mass. So you used to have energy as minus gmm by r whole by m, right? So instead of potential, when we are talking about potential, we'll have minus gm by r. Just this is the difference. So see, we used to have force as minus gmm by plus gmm by r square whole by m, right? Now gmm by r square we divided by m to get field. So we had defined field is equal to force per unit mass. We got the field as gm by r square, right? This was the value of field. Similarly, gravitational potential is given as potential energy per unit mass. Field is force per unit mass. Potential is energy per unit mass. Therefore, its value is given as minus gm by r, right? So I'll give you some questions which are based on gravitational potential. Just like, and gravitational potential is a scalar quantity, you just add it, right? Whereas field is a vector quantity. Gravitational field is a vector quantity, right? It is directed towards the center of the planet. It is directed towards the center of the planet. So I hope whatever we have read today is clear to all of you, right? Let us solve some assignments. I'll be sending you some assignment questions. Please solve them, right, so that we can have a discussion on them. There is something called as Kepler's law. Very simple. There are 3 Kepler's law given to you, right? First law is that the sun and the planets around the sun are in a system such that the planets are taking, so these are the planets, they are taking an elliptical path around the sun, right? This is called law of orbits. The orbit is in the form of an elliptical path. This is the first law of Kepler. Second law of Kepler says that if the planet is taking this much area or covering this much area, right, in some time t, right, or in some time, let's say, yeah, maybe let's say sometime t, or let's say dt, and the area covered by the planet is delta A or dA, then that area covered per unit time is constant. Area covered per unit time by the planet is constant and is given as angular momentum of the planet L upon 2 times of its mass, right? This L is the angular momentum, right? Angular momentum. So by this definition, since delta A by delta T is constant, L is also constant. That is angular momentum of the planet which is revolving around the sun is constant. Class, remember this equation, okay? Then third law says that the time period of this entire satellite to revolve around the planet is proportional to r power 3 by 2, or you can also say t square is proportional to r cube, where r is the radius, right? And sometimes we instead of radius, since we are talking about elliptical orbit, in orbit there is in ellipse there is no radius, right? So instead of taking r, we write here a, where a is semi-major axis. Try recalling, in an ellipse there is a semi-major and semi-minor axis. So semi-major axis. See, this is an ellipse. If this is an ellipse, right, which is longer in the horizontal sense, suppose this is 2a, then, and this is the center of the ellipse, right? Then this line or this half part of it is called as semi-major axis, right? So I'll be giving some questions which will also include gravitational potential and Kepler's law, right? These are the concepts which we just discussed and the other concepts which we discussed in the due course of class today. In case you have any queries, we'll be discussing those assignments in the next class, right? Thank you very, very much, class, for being present and giving so much attention. If everything is clear to you, whatever we read in the class, please raise your hand, else you can ask your doubt. Yes, class, get going. If there is anything that you want to ask, keep your hand unraised. And if you have understood everything, please raise your hand. Yes, class, get going. You may raise your hand if everything is clear to you in the chapter Gravitation, which we have read today, right? Okay, great. Thank you very much, everyone, for being a part of the class. Let us meet tomorrow and discuss the assignment questions and the next chapter, right, where we'll be covering the next chapter along with the discussion of these questions, discussion of some assignment questions which I'll be sending you very soon. So thank you everyone for being a part of the class. Let us meet tomorrow. This was your course instructor Khushwant Fatnani taking the revision session for all of you for the chapter Gravitation. Thank you very much everyone. Thank you. Thanks a lot all. Thank you.